Good day, everybody. Thank you for joining this session. I'm Jochem Vekes, and today I'll be talking to you about how to build a better test environment. To jump in it straight away, the reason I would like to talk to you about it is that in the latest World Quality Report, and also in the ones before that, published by Capgemini Sogeti, test environment management is still on top of mind of organizations. And I think the main reason is, we've reached this level of automation and working that the next bottleneck is, okay, we've automated everything. Can we now optimize that? Now, to jump in that a little bit deeper, I think it makes sense to start off with the definition. So asking Google for help, I Googled what's test environment management. And a couple of words stood out for me. It's function in the software delivery process, which aids software testing cycle by providing a validated, stable, and usable test environment to execute test scenarios or replicate bugs. Now, plotting this on what I'm encountering and what I have worked with in the past as well, but with what I'm encountering now with a lot of customers is that they don't have a stable test environment because a lot of teams have to share that same test environment. So, that data gets changed or systems are being updated and suddenly I'm working on a new version. So is this a validated environment? No, it's not. And then you could actually argue, is this even usable as a test environment? Because on one hand, I'm trying to execute scenarios. On the other hand, I'm trying to replicate bugs. Well, I think I can already conclude that if I don't have control over this environment, then I won't be able to replicate bugs. So simply put, generally we have a test environment available to us where we can execute scenarios. But it's pretty much a black box. And are we confident on what the outcome says? Well, I think generally it's accepting risk for what it is because, the alternative is probably too costly to just copy and paste a production environment. So we'll have to manage. Now, how do we get here? That's actually where I want to start off. So we started off with the monolith, everything in one big application, and it was fine. You can just develop with all the teams together and it's one big application. Either it works or it doesn't. But then we realized that was very, slow in improving and the market was changing faster. So we had to adapt more quickly. So we started splitting the two. We created a front end because we were happy that we had a website, because most businesses would go through a website thin client or a user interface at least, and you would have the back end. Now, some companies even took that further and went to the microservices architecture, where you would say, if you develop a new use case or a new integration where you say, hey, we're offering new product service or a Rico service, and suddenly we have now a basket that you can fill and you can pay for your stuff and we'll send it. So all these new evolutions of the application were just developed as a separate entity, as a separate piece of the bigger application. And this would make the updating of it much, much easier, obviously. Now with that, we even see that, well, actually in this piece, some communication challenges arose. There's more to be said about it as well, but there are now some companies that do it even slightly different. They focus on end-to-end teams with micro front ends. So they split it in a different segment. Spotify is a well-known example. They work in this fashion. But also if you look at bol.com, which is a Dutch example, they've also organized themselves in this fashion. And if I start mapping bol.com on this, then you could say that Team Inspire, Team Search, they're done by bol.com themselves. When you want to open the store, bol.com is very similar to Amazon, where it's an e-commerce platform, and with that platform, any other organization can open their own little web shop and leverage the platform. So here you suddenly have a whole group of organizations that are now running their store on bol.com's platform and thus being part of that product team, essentially. Now, if you look at the checkout part, this has also changed because now parties are specialized in processing payments, and Ingenico is one, Data Payments is one, but there are many more. So there's you can actually already see here that running a business does no longer only involve yourself. You're dependent on other people to make your business a success. And then we come to the value chain, because with that in mind, if you look at the entire value chain, and here is an example that I generally use, Simplified, explaining this example, is opening a lemonade store, right? If I want to open a lemonade store with my brother, and the goal is that we see some customers that are thirsty, then me and my brother, we can go to the local grocery store, get some lemons, and then create lemonade in my mom's kitchen, and then get my dad's car to move it to the place where I want to sell it, and then define opening hours and start selling to the customers that are willing to pay for that. And with that, deliver value, and as a result, obviously, we make a little money. But if one of these cogs gets stuck, the car is not available, or the store is out of lemons, or you name it, I get sick, then this model doesn't work, or at least it's frustrated. So we have to collaborate really we have to collaborate. That's the bottom line of it. And taking that a step further, if you look at the market, what's happening, product companies are realizing that as well. So again, two examples. One is very Dutch, Senseo. I think most of you may know Philips as a life sciences organization. Philips joined up with Douwe Egberts, who is a coffee producer. And they created Senseo, which is a coffee machine that really makes life easy for the consumer. Now, IKEA and Sonos did the same. They joined forces and they said, okay, well, we want to create an affordable, functional product that both is quality and payable and new. So with that, they created a lamp and a bookshelf that both function as a speaker as well with quality sound, because that's what Sonos obviously is known for. Achieving also IKEA's ideals of, creating affordable home for everyone. And I think the beauty of this is companies join forces to deliver value. Bol.com did the same in his architecture, and we see it here in the product development space as well. Now, the digital space is also moving in that direction. And, many know it as digital transformations and co-creations of it as well. Some examples here is Blendle, for example, where you have a lot of different news sources that you can bring together. Back in the good olden days, it was the RSS feeds that you would link together. And this one, actually, I'll talk about later a little bit here on the left-hand side. In the banking space or the financial space, organizations are starting to collaborate as well. So this is an app where you can connect all your financial services. If you have a current account, if you have a mortgage, you can all include them in this one app and have one overview. So the co-creation is now happening in the digital space as well. Now, before diving deeper into that, I just want to actually talk about a new paradigm. Get in a different mind space. So let's say you're an engineer and you just graduated, and you're going to work for this windmill company that does the maintenance of the windmills at sea. Now, you can imagine that if it makes sense that you get trained on maintaining these things. So the normal process would look like you get on a boat, the captain would take you to the windmills, an instructor would be there, you would go up in that windmill, do your thing, show that you're capable, and then come down and go back home. And then if you're certified, then you can work on your own. Now you can already imagine that going out to sea with that boat, the fuel, all of that, it's quite costly. So the industry there also looked, okay, what technologies are out there and how can we involve ourselves? Now this is one of the examples that was actually a co-creation as well, where a VR company, a software company, and then the windmill, I don't know if it was the manufacturers, I actually think it's the suppliers. They joined forces and created this simulation. That's a near lifelike simulation where people could actually get trained. Now you can imagine how interestingly this suddenly becomes, because if you get trained and if you know your way around the windmill, then you probably only need to go once to a real windmill and, show your thing. So if we look at what we're actually doing when we're assessing or certifying a professional, I think there's something that we can learn from that. Now, the most important things when we're looking to assess or certify something is what task is it supposed to accomplish? The next thing is the conditions under which it's supposed to accomplish a task. And then the standards really, show how well a person or a thing completes that task and whether it's according to expectations. Now with these three things, and I think you already sense it, I think there's a link to software development as well, but that we'll explore a little later. Different example, because actually what we've seen is not new. That VR in the windmill, yes, that's new technology, but the application of VR in the real world to train people is actually around since 1986, where the US Army, they realized that, if you have to train a tank crew, you have to go to different environments. Moving the crew to those environments or the material, it's quite a costly and time-consuming endeavor. And then even if you want to train in winter, you have to wait until it's winter. Whereas if you, actually taking this example where we say, hey, the task of this unit is to defend the strategic location, and I want to be in control of the conditions. So we have to train at night, at day. We should be on the move. We can defend it from a strategic or a stationary position. And maybe we have full capabilities or not. Maybe the left tracks are damaged. All of these conditions are something that could happen to, the environment you need to be trained in. And then still, even though you have these conditions, you need to be able to meet the standards. And in this case, we could argue that maybe not all systems should be ready, but most of them should be, or what's the accuracy of hitting the different targets. If it's less than X, then the team has failed. So with this, you can see how the tank crew can be assessed. Now, SimNet, that's the training facility used for the tank crews that was built in 1986. What they do, instead of the crew in training here on the far left, instead of bringing them out into the field, they would first train in a tank simulator that would be very like the tank. Maybe some of you know the play seats that we have for gaming. Now, it would actually be quite similar, maybe less comfortable. And through the screen, they would be in that virtual world where all of the conditions would be managed by their officers. So this would prepare them for a lot of different scenarios without taking the risk and the cost and the time to go into the field. Now, once ready, obviously there would also be a lifelike test or lifelike training, but most of the work could be done in this virtual space. So now we see that windmill companies, they effectively use virtual reality to train people, so they create a lifelike experience. The military already does this for quite some decades. Now, within the virtual space, we still very much want the real thing. But is that maybe because, within that virtual world, we're not sure what virtual reality means? So I think this question, it's one to think about. What would be a virtual world within your testing domain or within your software development process? Because I think here we can find a lot of benefits, and it's not only me thinking that. We'll get to some actual results in a bit. I've collected 4 examples of customers that I'm working with. I've plotted them on sort of a timeline where EDSN is the first one. I'll explain what they'll do in a sec. But I think around 2013 they started. Vizet followed after in 2018. Then we got some new regulations here in Europe. That's called PSD2, also known as open banking, in 2019. And lastly, I want to share an example from which I think we can learn a lot, which is ongoing today. Starting off with ADSN, let me jump into this actually from an example. ADSN is part of the energy market. And to tell you what they do, let's go through this. You live in your home, you want to consume energy. So in order for that to happen, we need to have a producer of energy on the left side or on the right side. We need a network, and we need your house connected to that network. Obviously, you might have solar panels, as do I, but just for argument's sake, let's say this is the way that it looks. Again, it's simplified. Now, there are 3 parties, actually more, but 3 parties mainly involved in making sure that you get your power. And that's the supplier, that's the network operator on the left-hand side, and it's the energy supplier, the guy or the people that you have a contract with. You pay them money, they give you power. That's actually how it works. Now, because it's an open market, all of these parties agreed that figure out who needs to pay who, because all of them need to pay their bills. It might make sense to ask one organization to manage all of that. So all of the data that is available within the energy market is collected and managed through EDSN. And they allow for you to be able to pay your bills based on the right information, and then that information is also the basis on which they can divide the money fairly. So when they started this organization, I think it was early 2000s actually when they kicked off, they had to figure out what they were actually going to be doing. So the most important thing is they had one application that they would be developing. That's that network node that you actually saw in the previous thing. That was the goal. Test this application. So they said, okay, well, if we have to do it, let's rethink how let's rethink it. I mean, we can do what we did, but then we get what we got. So they said, okay, we need to test this. Now, first, let's start with the database. Do we actually need the database for us to test the application? No, we do not. We need a response that we can process, but we don't need the database itself. Okay, so they started simulating that one first. So instead of the real thing, they created a simulation that would respond just like the actual database. The next step was, other services that are external. Do we need the actual live services? No, we do not. We can do with a virtualized version of it, much like the virtual reality that we talk about. And the same goes for the mainframe. They don't need the actual mainframe, a costly computer, but they need the result of it. So with this all rethought, they were actually, quite content because they didn't need full testing environments. They had simulations for testing their own application. So the only thing they needed to do is refactor the tests to be aligned with the simulations. still proving the use cases and the test scenarios that they had. So this was one of the first examples here in the Netherlands, at least, where they created a virtual environment allowing them to test and update their own system, even though they were dependent on all these different partners and components in their network, and also outside of their own network. Now, VZ was also an interesting example, because what they were aiming to do is connect all of the patient data for all the different players in that market. Now, we all know patient data is quite sensitive, you know, it's heavy on privacy. I mean, you don't want it to get out there. So what they create a secured network where all of the healthcare providers could communicate with each other, because everybody, the market, so the general practitioner, the pharmacies, even the healthcare insurance companies, realize that if all of the people in the healthcare chain talk to one another, communicate with you, and make the information available on your file, they can provide better care. Now, better care is not only good for you, but also for the wallet of all these insurance companies and whatnot. So they created this network node and allowed all of these different parties to connect over that network. Now, in a bit more technical, somewhat technical detail, this is what you see going back and forth. But I think what was the biggest challenge is that this network, they needed people to connect to it. So when you get a new general practitioner and you need to connect him to this network, let's take this example, you do need those other three actors here as well. So you need those pharmacies and the general practitioner post as well. Otherwise you cannot see if he is communicating the right information. What they didn't want to do is make the acceptance of the general practitioner dependent of the others. So if one would fail, all would fail. So instead of statically accepting people on the network, they needed to, well, they were working in a dynamic environment. It was ever changing. And it was not so much about the functional way of communicating, but sharing the right information. So the goal was accept one practitioner without affecting the rest. So how did they approach that? Okay, you have the different actors in the field, and we're looking to accept that new party to the healthcare network. All of their systems should be eventually connected to that network node that's VZ. So what they did, of all of these people, they created a simulation. And this is just a simplified version. It can be recording in the most simplest form. But they created a simulation of each actor in the system. And when you would say, let's accept this practitioner, then they would say, okay, well, let's activate these three simulations, let them talk, and then we can assess it. So in reality, the system would look like this. The prod environment, the production environment, all of the people would be connected to that, ensuring proper healthcare for everyone. And then all of the people that were ready to get accepted onto this prod environment would communicate to their acceptance environment, which was also open to those practitioners. And that would be connected then to the simulations. And you could always choose which simulation was relevant in which particular case. And there was always somebody looking at what information are they actually communicating. Because you can imagine that if you go to your physiotherapist, he doesn't need to know what the other doctors, or, you know, if, what's a good example? If your eye doctor wrote something on your file, the physiotherapist doesn't have a need for it. So that's really the most important thing when becoming part of the healthcare network, is that you communicate the right information in the right field. So this was how they actually accepted people onto their network. So in a generally, when we're talking about software quality, it's about the functional quality and not so much what you're communicating, the data that you're actually communicating. So I think it's a pretty cool but different example on creating a virtual world, allowing people to show what they've got, to assess them. Now, the next example, open banking. PSD2 is a European directive. I think most of you can imagine that the banks in this world are guarding your money as if it were Fort Knox guarding the gold. They want to prevent anybody from getting in. And even if you get in, they want to prevent you from ever getting out. Now, the Payment Service Directive basically says anybody that's developing an application or a piece of functionality and that asks you to give information to your bank account should get that information. So the Payment Service Directive mandates that banks open up their information if I choose to, much like this app here on the left hand side. Now that's obviously a big shock to the banks, because even if a memo leaks, the perception of a breach is very damaging to their brand. So they needed to figure out, okay, so how are we going to accept these third parties to develop against our own environments, even if we don't know them? So what they've did is, or in one particular case, what they've did, they had their normal, development process of developing the software, testing and accepting it, and then putting it into production. But next to that, they launched a sandbox environment. And that sandbox environment is basically a shielded environment where those third parties could play around. Now, play around might be a stretch, but going into that a little bit deeper, what this particular bank did is they said, well, let's use our standard security because we don't want to, go around that. That should be real. But we're going to provide a sandbox account, a front end, for these third-party applications. And they can leverage that sandbox to basically play around with the customer data. And if they're authorized, so then finally we know who they are. Once they are authorized, they gain access to a sandbox granting stub. Now, this one is very particular for one process, but that stub, behind it is a virtual, it's a simulation. It's a virtual world. They give that third party a VR goggle to see how the environment of the bank works. But when you start probing behind it, you still have that big firewall. You still have those big security, those firewalls that you cannot get through. So giving these third parties a virtual space, a testing environment, actually allowed them to safely and securely develop against the bank's environment without the bank taking the risk of exposing themselves to bad intentions. So this is how the bank, in this case, protected themselves. Now, actually, I want to get to the last example where we're going to take it one step further. Now, walking around this same bank, I was having some interesting conversations with some of the team leaders, and one of them said, we have all these different teams that are working on different software, and we have external dependencies as well of like credit checks and the market movements. So how cool would it be that all of these developers would have access to a bank in a box? And the bank in the box, would be portable. I mean, you probably can imagine that running all the applications of a bank and all the mainframes that they have available are, there's a lot of bare metal behind that. So you wouldn't be able to carry that around. But again, you don't need all of that bare metal to test against or to develop against. You need only the responses that that are made available. So the idea there to create that bank in a box really lived. And the goal was that, once they have a bank in a box, they can, work anywhere. It doesn't matter how good the internet connection is. They can work offline or any place in the world. We don't care. I mean, they need to develop against the latest and greatest of the banks. So with that idea in mind, we continued the conversations and the work. We said, okay, well, we need then to create simulations of all the integration points. And this is not an easy task, mind you. This is really a big endeavor. But, well, you probably know about the projects from Google where they want to build an elevator to the moon or transport people or teleport people from A to B. And they fail miserably, but the rest product is the world's best encryption. Well, that's a good failure in my book. So we know this is an ambitious project and we'll see where we'll fail, but this is the goal. Create all of these simulations, put them in a box, create different versions as services evolve. But basically, and now we're getting closer to it, this is the virtual world. These are the test environments or the development environments that are created, that are really just a couple of megabytes in space. I mean, one simulation generally is about, well, not even 1 megabyte. So you can really create lightweight environments that host all of the functionality that you need to assess your quality. And then we come back to that certifying that we were talking about earlier. So all of these simulations need to be developed, put into the box, and then be shipped off. All right, so how to move about that? Well, actually, we're already quite some steps ahead. We haven't, well, actually, we're not close to a full bank in a box, but we focused on one particular department, and that was the mortgages department. So this team said, okay, well, we want to start with creating that. And one of the biggest reasons they wanted to start with that is actually the following. They're using a package-based supplier. And this supplier develops the package-based solution. They validate it, and they validate it based on their customers' requirements. And then once ready, they ship the new version to that team. Now, that team tests it, and obviously there's a lot of wrong with it because the bank has evolved. All the teams created new services. Maybe some things have changed. So even though this team is testing, they're testing based on old specs. And keeping that in sync is the big challenge. So there's a lot of communication back and forth. There are a lot of issues that are being discussed. There's basically, simply put, a lot of waste between these two parties. Now, what they recognized is, guys, if we build this bank in a box, if we really get to that, we just focus on the most important integrations for our own application. We give that bank in a box to our supplier, so they can always test against a specific version of our landscape. And we don't need to open up our landscape to them. No, we can just send them that bank in a box. They run that bank in a box. They develop their new version. They validate it. And the cool thing is, they would know that if you test against version 2.15, then you know that you're testing against the same reality. You're both training in that same virtual space. That's the beauty of it. So we're not there quite yet, but like I said, it's better to fail with an ambitious goal than to fail with no goal at all, because you'll end up further. We've conducted some research, actually not ourselves, but we asked QA Financials to conduct a research on how valuable is this actually. We're curious as well. And they found that this particular team that we're talking about, together with actually another team in the US, they've become 40 times fast, or not 40 times, sorry. They shortened project times by 40%. And they found more bugs and less critical defects. So it already shows that the ambition of creating that bank in a box has been extremely fruitful. This report is openly available on our website. I think it will be attached to the webinar as well. So please download it or look for it, because it's really interesting read. Now this is the outcome, right? And you might wonder, hey, I'm ready to take control of my test environment as well. I'm ready to start creating those virtual realities. And for that, we've, together with the team that actually created that bank in a box, or at least started it, they've written up a customer journey. Like, what considerations did they have and what decisions did they take in creating that virtual space? So I would also recommend you to download this, to have a read through it, because it's a fantastic start of considerations that you should have while trying to achieve that 40% as well. Now, obviously, this is actually what I wanted to share with you today, because I think this is the most important elements of it. In case you have any questions, feel free to post them and we'll make sure we get to them shortly, so that you can get started on creating your own virtual spaces or your virtual realities for your applications as well. Thank you so much for your attention, and have a wonderful day.